An interesting phenomenon occurs when two systems interact. They become entangled. Because interactions are everywhere, understanding entanglement is important to understanding ourselves, our surroundings, and our universe. Entanglement may seem like a daunting concept to wrap your head around, but I'm going to explain it with something everyone is a little more familiar with. Food, specifically donuts and apples. I will explain two scenarios, one in which two systems are independent of each other, and one in which two systems become entangled.
I've convinced my sisters Amanda and Isla to help me with the demonstration in exchange for donuts. I set up a table with two covered bags, one holding a donut and one holding an apple. My sisters have no idea which food is in which bag. The different systems I will be analyzing are my two sisters and the bags and foods they interact with. To model unentangled systems, I have a separate set of donuts and apples to offer to each sister, and I'm offering them at different times so that my sisters don't interact in any way when choosing the bag. When both sisters choose independently, each has a 50% chance of choosing an apple and a 50% chance of choosing a donut. Creating a chart to describe all possible combinations of outcomes of each system reveals that there are 4 equally weighted possibilities. Both choose an apple, Amanda chooses an apple and Isla chooses a donut, Amanda chooses a donut and Isla chooses an apple, or both choose a donut. Notice, if Amanda chooses a donut, Isla still has a 50-50 chance of choosing a donut or an apple. Amanda's decision has no bearing on Isla's, and vice versa. When I performed the experiment, Amanda chose an apple and Isla chose a donut, but there was a 25% chance of any of the combinations I explained before to be chosen. Let's see what happens when I ask my siblings to choose from the same bags at the same time. Because my sisters now interact with each other in the same bags, the sibling bag systems have become entangled. Each sister still has a 50-50 chance of choosing a donut or an apple. There are only 2 possible outcomes. Amanda picks an apple and Isla picks a donut, or Amanda picks a donut and Isla picks an apple. If I know which dessert Amanda chose, whether it's a donut or an apple, I also know which one Isla chose with 100% certainty, because she must have the other dessert.
If two systems are entangled, information about one provides information about the other. In this case, if I know which dessert one sibling chose, I also know which one the other chose.
Let's send Isla to her room to open the bag while Amanda stays downstairs. If I observe which food Amanda chose, it appears to have affected the state of Isla's bag because now I know with 100% certainty which food she has instead of having a 50-50 chance of Isla observing a donut or an apple. Einstein called this spooky action at a distance.
Did information just travel faster than the speed of light? Not exactly. The problem is that the instant I observe the dessert, I have the useful information, but Isla does not. The information we learned about Isla's dessert from Amanda's measurement only becomes useful to her if she knows the result, which does not occur the instant we observe Amanda's dessert.